Again, this is a continuation of the Test 3 review questions, and we're down to question 19, where it gets into polynomial division. This is kind of one of those topics where we have to go off to the side and do some background work and some background information in order for us to proceed, because we need the skill of synthetic division as we move forward talking about polynomial functions. Before we begin, though, I want to review the process of simply good old everyday long division that you learned in probably 4th or 5th grade. So if you have the question 4,275 divided by 27, a couple of things I want to make a note of. Remember that this first number here, the term is called the dividend, and it's divided by 27, which is the divisor. The result you get is called the quotient, and you possibly could have a remainder. Okay, you may or may not have a remainder, but that's kind of where we are. So if we're setting up our long division problem, the divisor goes on the outside and the dividend goes on the inside. And then we begin. How many times will 27 go into 4? And we know that it doesn't. How many times will 27 go into 42? It goes one time. 1 times 27 is 27. We draw the line and change the sign because we're supposed to subtract. So if we do that subtraction, we have 12 minus 7 is 5. 3 minus 2 is 1. We get 15. And we bring down the next number. Then we go through it again. 27 goes into 157 5 times. 5 times 27 is 135. Again, we draw the line and we subtract. 7 minus 5 is 2. 5 minus 3 is 2. We bring down the next term, which is 5. And we do the process yet again. So 27 goes into 225 8 times. 8 times 27 is 216. Draw the line and subtract. 15 minus 6 is 9. So in this case, we have a remainder of 9. And typically, especially in algebra, we would write the answer as 158 and 9 27ths, or the 27ths will simplify into 1/3. So either answer is correct. We do typically simplify our fractions. And so we're going to use that same process to do long division of polynomial functions. Kind of the downside, or perhaps what you might find challenging about it, as most students do, is you got to deal with all of the variables. So here again, you have the x plus 3 is our divisor, and our dividend is x to the third minus 4x squared plus 5x plus 2. Now, one thing I want to point out to you, notice how it goes third, 2, 1, and then no exponent. You should always have your dividend as well as your divisor in descending order of exponents, and you don't want any missing pieces. So if you skipped from 3 to 1, you'd have to fill in with perhaps a 0. So we begin the process. X divides into x to the third, or think about it, what number times x would give me x to the third? Hopefully you realize that's x squared. So we're going to multiply. X squared times x is x cubed. X squared times positive 3 is positive 3x squared. Then we draw the line and change the signs to do the subtraction. Minus 4x squared minus 3x squared is minus 7x squared. X cubed minus x cubed goes away. and we bring down the next term. Then we begin the process again. Set negative 7x squared divided by x, or how many times will x divide into negative 7x squared? So we need a negative 7 and an extra x. So negative 7x times x is negative 7x squared. Negative 7x times positive 3 is negative 21x. Again, at that point, you want to draw the line, change the signs. Plus 5x plus 21x gives me 26x. Minus 7x squared plus 7x squared is 0, which is what I needed to happen. And then we bring down the next term. Do it again. X times what would give me 26x? I need 26. 26 times x is 26x. 26 times 3, let's see, that's 8, 78. Okay, then again, we're going to draw the line, change the signs. 2 plus 78 is 80. And negative 26 plus 26 is 0. So we have x squared minus 7x plus 26. But don't forget about the remainder. You don't write R80. We'd write plus 80 over the original divisor, x plus 3. And that's long division. Now, long division is used later on with rational functions to help you find the slant or the oblique asymptotes. That's the primary reason we talk about it here. Now, synthetic division is kind of a shortcut that many students actually enjoy once they learn the process. And so a couple of things about synthetic division, you basically set it up with this little box, and inside the box is going to be the divisor. And beside the box, you write the coefficients. You only use the coefficients. You don't use the letters of the dividend. Okay, and then you begin this process of adding in multiplication and adding depending upon which direction you're moving. Basically, the way it's described in a former textbook, if you're moving diagonally, you're multiplying. If you're moving vertically, you add. So you add on the vertical and you multiply on the diagonal. So if I'm working this particular problem, my divisor is x minus 2. I'm going to set that equal to 0 and solve for x. So x equals 2 is going to be my divisor, which goes in the box. In my dividend, I have negative 3x cubed, positive 7x squared, positive 4, minus 1. Basically, I'm able to eliminate the x's, and I can deal with just the numbers. Okay, so then we begin the process. We drop the negative 3 straight down below the equal bar. Then we multiply. 2 times negative 3 is negative 6. 7 plus negative 6 is positive 1. 1 times 2 is 2. 4 plus 2 is 6. 6 times 2 is 12. Plus negative 1 gives me 11. Now, in synthetic division, this number at the end here, the 11, represents the remainder. We've divided out an x term, so we started with 3x cubed. So now I have negative 3x squared plus 1x plus 6 plus 11 over the original divisor of 11 minus 2. Okay, so that's synthetic division. And again, synthetic division will be used a little bit later to help us find the zeros of a polynomial function.